Okey, Assalamualaikum dan selamat pagi semua.
Salam.
Okey, boleh kita mula ya?
Boleh.
Puan, boleh kita mula?
Boleh.
Okey, teruskan.
Okay, kejap cik. I start presenting.
Besarkan slide. Okey.
Sekejap ya. Okay. Assalamualaikum and good morning to our panel, Puan IR Nur Juliza Azlina and our moderator Encik Wan Ahmad Faizal. Today we will be presenting about the Smart Vehicle Motion Detection Device, which is SVMDD. Our SV is Puan Farizan binti Zakaria. So my name is Nurin Natasha binti Nazman with card metric number 01DKA18F2039. So for the content in this project, in this proposal, which we got introduction, problem statement, objective, scope of study, methodology, result analysis, conclusion, and our recommendations. I will be starting off with the introductions. In this introduction, generally, human and environmental factors seem to be the major cause leading to accidents. Accident could be averted as long as the road user are alert. The Smart Vehicle Motion Detection Device, SVMDD, is created to reduce the accidents that keep happening in front of school areas so the pedestrians and school students will be safer. This device detects cars and that are exceeding speed limit and give warning to the drivers.
My name is Muhammad Fahim bin Abdul Aziz. My matrix number is 01DKA18F2033. Problem statement. While the rate of accidents increases, the rate of traffic jams due to accidents seems to be increasing as well. In Malaysia, road accident keeps happening in front of schools. This is due to the driver's behavior and conditions of road. The front areas of schools tend to get packed and busy with parents or caregivers when the school has ended. This is when road accidents easily take place for either from negligence or lack of concern of driver to the surrounding. This eventually causes collision that involve at least a moving vehicle, which cause damage to property or injuries including death. Road crash in front of school zone. From 2000 until 2009, this is the graph road crash in school zone.
So I will continue with the in front of school accident reports from online news. So there are several cases that keep happening in front of the school. So on the September 25th, 2020 in Banting, Kuala Lumpur, the victims in an effort to escape the gunman rammed into a group of students and several other cars during the 12:45 p.m. incidents. And the second report is 3rd September 2020 in Alor Gajah Melaka, which is 2 from 5 students were seriously injured, while another was slightly injured in an accident involving two motorcycles in accident in front of Sekolah Menengah Kebangsaan. So the next one is the in Ipoh Perak, a Form 4 student died after his motorcycle collided with a car that was making U-turns on Jalan Tanjung Rambutan. And then the last one is on January 9th, 2021, Kuala Pilah, Negeri Sembilan. The victim died after riding motorcycle with his father in accident on Jalan Senawang, Kuala Pilah. Just for the next one is the objective.
The next one is objective. Number one is to design a smart vehicle motion detection device using Arduino circuit. Number two is to develop a sport speed test infrared sensor using motion and color warning using SVMDD. Number three is to test the SVMDD for carry out the speed changes according to JKR specification in standard arahan teknik Jalan 12 slash Jalan 12 slash 87. The next is scope of study. The project focus on reducing accidents that keep happening in front of school zone caused by road users. We create smart vehicle motion detection device to reduce road user speeding in front of school zone and to minimize the cases. Expert to test device is JKR. Using sensor technology to detect car speeding over the limit in front of school. Next, the flowchart of SVMDD. Step 1, design smart vehicle motion detection device. Then develop the SVMDD. Then test the SVMDD. Determining the type of device and software. Step 2, designing the Arduino circuit. Next, coding the Arduino circuit with LED and development of the Arduino circuit. Step 3, testing the device with the road users and validate the developed device with JKR. Then analyze data collected from testing. Step 4, supervise.
So this one is the finding of our project. Step one is the research design, which is we create to put the device is in front of our school. So it's called the Smart Vehicle Motion Detection Device for speed detection. Purpose of this design of SVMDD is for speed detection warning. So the second step is the design. We design of the SVMBD using the circuit.oi website. There are several components inside of this picture, which is the Arduino Uno IR infrared sensor, which we using two inside for this prototype, and then the red and green LED resistor, male to female jumper wire, male to male jumper wire, so solderless breadboard, 9 volt alkaline battery, LCD, 16 times 2 display, and rotary potentiometer. So in this prototype, we are using coding using Arduino Integrated Development Environment, which is the Arduino IDE. We are using this because it is simple programming language, and the IDE software operate and on any operating system, and really open source software and hardware, low cost boards and peripherals. So the coding setup in the SVMDD Arduino with the IDE software for our prototype is, which is the liquid crystal to read data and understand data. Void setup, time card detection variable based on the void loop and float distance, which is we need to set up the time detection as the car pass by for the prototype to detect. So the LED setup, positively and negatively set current coordinate for LCD, which is the for the of every alphabet, they need to coordinate, and then display overspeeding, which is the calculations, 0.5 3 times beeping for the LED light.
Okay, very good morning. My name is Kishan Kamachi, matrix number 01DKA18F2081. And for the steps of the prototype of the SBMDD, here is just an overall explanation. Like we purchase all the materials needed for the prototype and prepare the coding. Start with installing the Arduino Uno with the coding using the preferred IDE software. Assemble all the parts to the Arduino Uno and connect the wires with our components. Arrange the components in a proper box, and finally insert the battery and we start with the testing. So on the left is our actual device, and on the right is a small scale model that we have prepared. As for the start of the development, first and foremost, we start with the coding. So once all the coding is ready and prepared in the laptop, we transfer the coding to our Arduino Uno with the USB. Once we transferred all of it, first we move on with connecting the Arduino Uno with our components such as the infrared sensor, and we test it to see if it's actually functioning. And once we actually connect it to the infrared sensor, we move on with our LED lighting, which should be connected with the infrared sensor. And after that, we move on to the LED. The LED actually requires quite some time of progress because we'll be connecting the the LCD with the Arduino Uno and our sensors, which is why it gives us the speed, and the LED like flashes the red light and green light once it's like actually like working and all that. So once all of this is like make sure everything is functioning, that is when we like place all our components inside the casing that we ordered and place it according to our arrangement so that the wires doesn't collide and doesn't come out. Since we are using the jumper wires, we are just connecting it to our component, so there's a possible way it will come out easily if we don't prepare it properly. And once all the component setup is done, we this is just a very simple outcome video of our prototype, which sorry, okay, the video should be playing but it didn't play. Maybe later on we can replay the video. uh, I think we should move on with the test of SBMDD prototype.
Step 5, test the SVMDD prototype. To test in terms of functionality of smart vehicle motion detection device, the functionality of SVMDD, frequent testing in front of school time, analyze the data, histogram, JKR standard specification, road furniture, design specification inspection, check quality and safety of the device.
So the next one is actually our result and analysis of the prototype. So there's three tests that we have been going through with this prototype, which is the continuity test, resistance test, and the voltage test. As you can see on the table, there are our value and the result, which is our resistor and the LED. We are looking for the functionality. Is it okay going with our prototype? So and then there's a visual inspection on our prototype itself. There's no flaw or cracking as we've been through the test several times. And then this is the positions of our prototype when we put on the place site when we using the prototype itself. Observer is the position of the device, which is similar to the spot speed study, collecting data. And then observer is where we putting the prototype, which is in front of the school before the car pass by, something like that.
The next one is data analysis, class speed and fraud. This is frequency of cars, um, 15 to 100 cars. We make in several of school. And data is okay. Next discussion from the data received on the graph above, 66% of the data show that cars speeding exceeding 30 km per hour in front of her. Only 34% of the vehicle users followed the signage shown to drive 30 km per hour in front of school. We can see that this is the reason of accident increasing in front of school as they are not aware of their surroundings.
As for the conclusion, this project completely achieved all of the objective. The main objective was designing the smart vehicle motion detection device for road users using the Circuito, IO, and IED software. The SVM-DD is developed using simple materials that are easy and cheap, which can be constructed very easily. The overall objective of the SVM-DD is to give awareness to road users regarding the risk of accident caused by speeding at the accident potential area, causing danger to the school students mainly. For the effectiveness test, we have done the inspection test for the components to check the quality of the component that has been used in the device. We also have tested using continuity tests, resistance tests, and voltage tests as we showed just now. From the results, we can conclude this device is functioning properly. We hope this project can solve the problem of road users so that they don't have accidents due to speeding in front of school. We really welcome the panel's view regarding the project. Comments are very important to further improve our project so that the implementation of the project can be well preserved.
So there are recommendations for our project. There is something must be done to improve our smart vehicle motion detection device. This device can give a good impact in construction field in term of impact in sa- safety and sustainability in future based on the result and comments that has been obtained during the validations and presentations. There are several things that can be proposed for the further actions. Based on the findings and conclusion, there are few recommendations which are the cost of the implementations of the project should be taken into considerations. And then we need to improve our device with a better place for the components, and we should make more research to test run of components as well as device in order to get more accurate readings. So thank you for
Thank
listening.
you.
This is our end of
Thank you.
presentations.
Yes.
Okay, Q&A session. Q&A session eh.
Tadi ada cakap related dengan ATJ 12/87 kan?
Arahan teknik jalan.
Ada?
Ha.
So di manakah yang relatednya tu?
Patutnya kami buat specifications untuk prototype tu macam design dia, tapi kami tak letak dekat dalam tu. Sebab untuk it's take we had several problems regarding about the teknik jalan thing. And then because of the COVID and stuff, maafkan kami.
So yang design ni memang tak refer ATJ tu lah kan? Ke ada di refer juga?
Macam waktu untuk letak bahagian depan dia sikit-sikit je lah, not fully lah pun.
For the placing of the device, kita ada refer the distance from the school, from the
Lebih
road.
kurang macam tu.
Ada rekod.
Okay, masa ni memang contoh sekolah yang diambil tu apa ni memang menempati ke ATJ 12 tu?
Maksud puan kedudukan device tu ke?
Tak, sekarang ni sebab kata tengok based on distance sekolah apa semua kan. So review on ATJ lah kan. So
Ha.
masa tu memang distance tu bila diukur balik memang menepati ke dalam
Yang
ATJ tu?
yang 100 meter sampai 200 meter tu. Yang itu kami buat anggaran sekadar anggaran je lah buat masa sekarang ni, sebab macam waktu kami testing prototype tu kami letak dah bahagian betul-betul depan sekolah, tapi yang itu sebelum raya sebab macam anggaran sebab kereta kan macam banyak waktu tu, tapi not fully ikut apa yang akta jalan petugas.
Yes, because initially like we wanted to test in front different school, and then since the movement control order all the implement tak boleh nak keluar banyak, so like masa kita initially testing tu we went to a different school nearby.
Untuk dapat more accurate data lah, tapi disebabkan asyik pindah sekolah, so we keep changing place waktu ambil data tu.
Okay. Cuma saya nak tahu based on you punya yalah yang you buat on-site kan, you pergi test kan. So berapa you punya data collection?
Our data collection is 100 cars based on the graph just now.
Bukan based on car, dia punya location.
Location.
Sorry miss, like data based on the location.
Location yang kita orang pergi tu ke apa?
Yang you all buat lah, sebab tadi you cakap selalu ubah lokasi kan?
No, as for the final location we memang kita redo balik for 100 vehicles.
Okay. Kenapa you tak collect? Ini saya nak tanya lah. Kenapa you tak collect? Sebab you banyak berubah lokasi. Kenapa you tak collect? You buat comparison every lokasi tu. Sebab you just pakai satu lokasi buat analisis kan?
Yes.
So bagi
Betul.
macam saya bagi tahu saya industri, takkan saya nak based on satu location. Bila
Betul.
you bagi multiple location, so you punya akurasi, data accuracy tu lagi tepat lah. Sebab you banyak lokasi. So kita tahu memang behavior orang Malaysia ni depan sekolah pun 60 km sejam.
Betul pun.
So yang tadi saya cuba dapat dan satu saya tak tahu mungkin lokal ataupun memang kawasan penduduk kat situ memang semuanya pakai supercar. Mana saya tahu. So dia memang tak boleh nak pergi speeding ke 30 bawah 30 kan.
Betul pun.
So tu yang saya duduk tengok, you ambil satu saja location. So bila saya tengok location tu pun bila you tengok, sebab itulah result you based on data collection tu lah. So saya tengok kalau sekolah tu keluar-keluar memang jalan lah kan.
Betul.
So you kena tengok lokasi you. Mungkin you keluar-keluar jalan memang main road. Memanglah speeding laju. Mungkin data you ambil tu collection tu mungkin depan tu dalam sekolah dalam perumahan, sekolah kampung. Sebab you cakap you banyak ubah lokasi tadi. Saya bila kenapa you tak select sebuah location tu. Tapi you pergi ambil satu sahaja.
Yes, like finally kita tak fikir pasal comparison tu. We just went to like buat satu je macam tu.
Sebab kita ni. Okay, lepas tu yang ni sekarang saya nampak you macam buat speed track je kan. Okay, yang ni banyak, okay, yang ni kereta ni lebih ni. Sebenarnya you punya end of you punya apa yang you nak sebenarnya? Just nak tahu okay kereta melebihi 30 km sejam lepas sekolah ke itu conclusionnya, atau apa benda yang you nak?
Actually yes, the device tu we actually fitted with LED kat depan device tu. So when the car speeding, they actually light berkelip. If normal speed it will be like green light, and like over speeding will be red light. The video I couldn't play just now. So like that is our main objective, to alert the drivers. Maybe like the driver they don't notice they are going fast or not. They just feel like they are driving in normal speed. So when they reach the school area and they see the light that's blinking, so they are like alerted that they're actually speeding. So they can slow down and like see the environment. Ada school student ke tak? Is it safe?
You punya apa ni lampu tu yang nak bagi alert tu?
Yes.
100 ke 200 meter ni lokasi lampu tu di mana? Kat observer ke?
100. Actually lampu
Tengok
tu
you
dia
punya
dekat device tu saja.
dekat device tu.
Yes.
You letak
dekat
device
device.
tu dekat mana?
Depan sekolah.
Lepas tu dia alert depan sekolah.
Tak, maksudnya let's say lah a car pass by, right? Lepas dia pass by tu yang detect tu the car that yang dah melepasi daripada benda tu. So yang kereta dekat belakang dia tu boleh nampak lah there's like a red light there because the car in front of it already over speeding. So the back one is gonna slow down lah like that.
Orang belakang lah.
And also
orang
the
belakang
surrounding,
lah.
if the students are like waiting to cross the road or they are like parents
Yeah.
waiting to pick up the children, they can actually know that there is a speeding car on the road. So they
Yeah.
will be like, their movements towards the road should be slower because there is already a speeding car in the road. The light is like blinking there.
So dia punya conclusionnya tadi memang nak alert yang siapa? Orang yang tengah memandu laju ni ke orang belakang?
Orang yang tengah mandu and
tengah
the
mandu
surrounding
Orang
people
belakang.
also. Orang
Surrounding
belakang,
Sepatutnya
orang
you
yang
punya
kat luar
Ah.
surrounding.
Sepatutnya you kena ni bagi tahu lampu tu ada kat depan. Tapi you lah device you kena letak mungkin 100 meter sebelum sekolah lah. Sebab bila you letak depan sekolah, you tak boleh buat apa dah. Budak sekolah keluar je memang yang you collect data daripada paper tu, itu akan jadilah. So position, location tu pun kena tepat lah ya.
Okay, puan.
Okay, puan.
Sebab saya duk mencari mungkin saya tak tahulah sebab yang saya nampak you just record speed tu je. Saya tak tahulah pula you cakap nanti kot ada tiba-tiba sound yang besar ke ataupun tiba-tiba ada device tools ke kat jalan tu tiba-tiba kereta tu berhenti. Yang tu yang saya nak tahu sebenarnya. Sepatutnya kalau you cakap kalau you tu nak bagi amaran sepatutnya you kena letak you punya device dekat 100 meter yang atau 200 meter. So
Before
mungkin
the school.
50 meter dah keluarlah you punya warning sign tu dekat driver yang pandu laju tu. Bukan orang belakang alert tau. Orang yang driver laju.
Okay.
Boleh puan, boleh.
Okay, itu je.
Okay, terima kasih untuk grup dan terima kasih juga untuk Puan Juliza.
Terima kasih puan. Terima
Okay.
kasih Encik.
Thank you,
Terima
bye.
kasih puan. Terima kasih tuan.
Okay, terima kasih. Boleh bersurai. Super juga tadi. Saya pun nak tahu dia orang pakai alert system tu pakai lampu ke, pakai siren ke.
Sebab dia orang dah hantar saya awal lah tu. Saya itulah ikut dia tak explain tu. Rupanya explain benda yang sama kak.
Okay puan. Nanti
Okay.
rubrik tu nanti saya dah siapkan dia punya marking dia tu. Dah tekan, lepas bagi markah, lepas tu di bawah tu memang dah auto generate saya dah buatkan. Rasanya puan terus bagi pada Dr. Sunita terus pun boleh.
Ya, ni dalam format yang sama ke?
Format Excel.
Okay.
Format Excel. Okay puan, terima kasih.
Okay, sama.
Assalamualaikum.